Welcome to qnawire.
We have an horizontal plane and a string in which a bird is going to sit down over here. We're told that the mass of the bird is equal to 22.4 grams, which is the same as saying 2.24 times 10 to the minus 2 kilograms. And we're told that this bird is going to generate an angle in between the horizontal and the strings equal to theta, and we're going to have two different tensions on our strings. So for this, we want to, first of all, find an expression for t. Second of all, finding value for t with an angle of 7.3 degrees. And for 3, we're going to find the same result with an angle equal to 1.4 degrees. So to find the tension, what we're going to do is employ the condition of equilibrium of forces, that is, sum of the forces needs to be equal to 0. So the sum of the forces of x is going to be always equal to 0, because this is going to be regardless, equal to 2t times cosine of theta minus t times cosine of theta. So regardless of the angle that we're going to have, this is always going to be equal to 0. On the other hand, the sum of the forces on y, this is going to be equal to t times sine of theta plus t times sine of theta minus mg, and this needs to be equal to 0. So what we're going to get is that 2 times t sine of theta is going to be equal to mg. Thus, the tension will be mg divided by 2 times sine of theta. This is going to be the expression for the tension in this scenario, and this is going to be the answer for part 1. Now, for part 2, we are going to just plug in the values that are required from us. This is going to be with theta equal to 7.3 degrees. The value for tension is going to be equal to the mass, which is 2.24 times 10 to the minus 2 kilograms, times the value for gravity, which is 9.81 meters per second squared. Over here, if your professor employs gravity as 10, you can plug in that value for your calculation, and over here 2 times sine of 7.3 degrees. This is going to give us as answer 0.8647 newtons. And now for the second case, for theta equal 1.4 degrees, the expression is going to be the same, but the value for tension is going to change. And the tension that we're going to find is going to be equal to, it is going to be 4.497 newton. And with that, it would be all. Thank you very much, and have a good one.